and hopefully I'll be live in few minutes. Let me wait till it's live and then I'll start. Okay, I guess I am live. Let me reset the timer, tweet about it. Okay, now we can start with part where we left off yesterday. So this was the part where we left yesterday. We need to get this particular error by overflowing the stake, but we got some we got the overflow but not the correct one. That's the issue. So forge test dash empty, and we get the overflow. We got the overflow, but there is some panic, arithmetic overflow or underflow or overflow. So we try to do this twice. Let's see. Yeah, if this runs, okay. What was the issue? What was the error? Okay, out of fund. Okay, we don't have that much ETH. I I do understand that we don't have that much ETH. So what else we can do? We can just yeah, I know. We can create this address. Just a second. We can create an address random, then make addr random. Next is vm.deal type uint112 dot max. Okay, was it a random comma? Yes, that that was it. So first the address and then the amount to deal. Did we do like 1.5? No, uh, not 1.5 plus 1 ether. That should do. Then hopefully we won't get the out of fund error. Oh no, we need vm.prank random. arithmetic over. Okay, I will try to understand what's the issue. So I guess this this will be again console log, and no was the issue, but I can't like point it out where the basic issue is. Let it call. Okay, the arithmetic overflow underflow means in here, where here, I guess it's more values than it can handle. So let's stop hold all the things. UN 256 256 dot max. We'll just print those out and see the values. Above here. No, that's not the case. Then what's the problem? Okay, so problem is here, I guess. 1E18. Does this work? Can I just say UN 256 max? What will happen now? I won't get an error. That's for fucking sure. Okay, then remove this. Does this work? That passes. Now we try to, sorry, we try to add one more ETH. Okay, next call did. For some damn reason, it's not working. So we send this. Okay, got it. We also need vm dot prank random random. Okay, now it should give me the correct error. Yes, it did what we wanted. So I guess that's fine. We did the correct thing. Now stake manager. What else? Okay, we are still testing this part. We are still testing this function. So we tested this branch, this. Now we need to test this particular branch where we try to go, try to like set unstake delay and then like try to decrease it and see if we get this particular error. Similar, uh, we are gonna do the similar thing what we did here. We're gonna uh, just like add stake first time and then try to add stake again, but with lower value, um, lower unstake delay. So function test reverts on is it unstake delay? Yes, reverts on decreased unstake delay public. We can just say entry point dot add stake, then say 100 value equal to 1 ether, and vm dot expect revert to, we just use this and see if it fails or this works. We don't have to use bytes. I don't remember, so that's why I want to check. Okay, next call did not revert. Okay, oh sorry, 50. Oh, okay, so we don't need this bytes part. Let's remove this. From here also we can remove this, and here. Okay, so we have done all the required functions. Now we have to check if deposit is set correctly. Deposit info struct, and we can get the deposit, right? Get, okay, but there is no, yeah, there is expose function which is get deposit info. We can give the account and it will return the deposit info struct. And while we check that, we also will also check this part, the unstake delay. Function test add stake emits event and sets deposit info public, and we can start here, uh, entry point dot add stake, and here we should create like a variable stake equal to 1 ether event 1256 unstake delay seconds. Unstake delay new duration before. Okay, just a minute, let me check. Withdraw unlock. unlock stake. Okay. If unstaked, not staked, already unstaked, withdraw stake, block time, block.timestamp. Got it. So we can set it to like 100. It doesn't really matter. So we need to test if the value is correct. So stake and then unstake delay seconds was this. Oh, does it? Okay, you went 32. And then in the deposit info, yeah, it's event 32 withdraw time. How is getting set? Let's see. Okay, it's 0 by default. And when you unstake, okay, when you unstake, it says the withdraw time. Understood. Let's change this to event 32. Now we need to check the event. So expect emit, then I think it's we need to import it, right? We need to import stake manager, and from stake manager we can access this deposited. No, not deposited. Not this one also. Which event was that? Take no, take locked. Okay, yeah, it's is here. We know all these three values. So let's go up and import I stake manager. I stake manager. Okay, so that's a now we can access the event selector in our function with this. So hashtag manager dot what was this? Take lock dot selector. No, expect emit. Okay, yeah. So we have one indexed value, so it will be true, false, false, true, and then the address of entry point, and then we have to do this emit. Okay, sorry. I have to brush up on things again. True, false, false, true, address of entry point, emit I stake manager dot stake locked, and then address this, then stake, and then unstake delay seconds. Oh, then okay, now that's true. That's done. We can. We also need. Can we access iStake manager dot deposit info? Yes, we can. So we can say deposit info equal to entry point dot get deposit info and then the address, which is this one. Okay, let me take a break. um, I'll be back in a minute. Okay, so I'm back. Now what we should do? Okay, this is memory. We have this. I think for this we can create like a expected memory, expected deposit info. So which will be stake manager dot deposit info, something like this. Let me see. So stake manager deposit info. Yeah, deposit info, deposit, so info dot deposit. Okay, I don't know how that's getting set. It's UN256, but it's not stake. We have the stake value here. Oh, okay. It's deposit. Okay. Yeah, obviously it's deposit. So for in our case, deposit will be 0. Then comes what? Then comes staked. Staked equal to true. Now we have actual stake, which will be stake. Now unstake delay seconds, unstake delay seconds, and last but not least, which is withdraw time. Withdraw, sorry, withdraw time to 0. Now that's 0. We can what's oh, okay. We need to typecast it. Now we can use like assert equal to. I remember this only. dot encode packed and then put deposit info here, and then for next do the same thing. 256 encode packed expected deposit info. Okay, just a second. No, There shouldn't be an error. Yeah, that's correct. This is oh, okay. I have to check. Like I forgot how to compare structs. Okay, I do remember we can't directly check it. Yeah, can we get hash of whole struct, not just single values? Yeah, we that's ridiculous. I'm not gonna encode each value. Okay, does deposit info? Oh no, this will obviously fail. Yeah, it expects some value that can be casted to boolean, but it's not. So how to assert? No, boundary solidity, boundary check struct assert equal to okay, assert equal to unit testing. Struct. Okay, I don't. Um, I found a. I found something. I don't know. Um, let's check deposit. Is that same? Oh no, not that test. We need to run other test. Yes, that works. Yeah, I don't remember how to test. How to assert, like assert test? No, assert struct. Struct. Make assertions. No, I need to test. Check. No, hash whole struct. Oh, is it? Okay, so it's not encode. Oh, okay. I was on the right path. Yeah, so you can't pack it, but you can encode it with whatever is that is the padding and all. So you can ABI.encode it instead of ABI.encode packed. That's the basic idea. Okay, now that's done. I guess we have tested add. Yeah, we have tested add. Let me let's go to the browser. Localhost 5500 coverage core take manager. What's okay? I'm pretty sure we can test this as internal view only. Where this is getting used. It's not getting used anywhere. Back to VS Code. Okay, in entry point simulation, we are testing it. Factory info, get info on the fact. Okay, that's correct. Where is this entry point simulation? It's in the code. Oh, so we have to test this also. Write test for this. Yes, and I guess at that point we'll cover that function. So it's view only function, so we don't really have to think about it. Instead, we can think about these now. Withdraw to uh, this is yeah, this is for deposit, this is for stake, and this is for stake. Okay, so we know our next steps. What are those? Which is getting coverage for these. So unstake or unstake. What's the plan? So first it gets the deposits. It checks if stake is there. No, it checks for unstake delay. So if there is unstake delay, there is no unstake delay. There is nothing staked. Info staked already unstaking. Okay. So if it's false, it will throw this error. I guess. Okay. Now withdraw time. It will set the withdraw time to something. Will will say stake is equal to false, and the event will be emitted. Yeah, this is pretty straightforward. Okay, yeah, that's straightforward. Let's write function. Okay, I'll also spend like few streams on how to write good tests or how to structure tests. I don't know that, and I'm just like randomly creating functions. I'm pretty sure this is not the optimal way to go about it, but right now that's the thing we have. So let's go for that. Let's go with that, not go for that. Test unlock stick, right? That was the name. Yes, unlock stick reverts on no stake. Public, then entry point dot unlock stake. We don't need anything. Okay, let's copy this. No, not staked. And we are just gonna say vm.expect revert. Yeah, I guess that's about it. Does this work? Yes, we got the error that we expected. For getting this error, we need to set and we need to stake and unstake. Uh, no, we need to add stake and then call unlock and then call unlock again. Test unlock stake reverts on stake equal to 0. Then say public. First we need to call like entry point dot add stake, which will set it to true so that we can call to say unlock stake. Yes, let's say 100 and go here, value equal to 1 ether. Now we can call entry point dot unlock stake vm dot expect revert. Now we will get this error. Yeah, we got this error. We'll get this error when we call it twice. Hopefully my assumption is correct. Oh, that thing, yes, not assumption, my understanding of that function is correct. Now we can add stake and unlock it, and we'll see if we get this event emitted and deposit info. What what should we call it? Yeah, deposit info struct we get back will have withdraw time and stake set to false. Timestamp plus, yeah, yeah. I think it's straightforward. As I said, function test unlock stake sets deposit info and emits event. Also, I want to check like how these guys name their tests, because my test names are getting larger and larger in length. So I want to check it in a different way. No, I want to like name them in a different way so that they won't be like ridiculous. Add stake, we are getting 100 value set to 1 ether. Oh, sorry, UN 256 stake. Also, this is a good way to go about it where you name every variable instead of using random values. So you will have some recollection of what it was once you come back. And stake delay sec and then stake. Oh, it was UN 32. We can call entry point. No, vm dot expect emit to be, what should it be? So we need to check this, but event name is stake unlocked. So true, false, false, true. So true, false, false, true. Address, entry point, emit I stake manager dot stake unlocked, which will be address dot this, and then withdraw time. Withdraw time is the set UN 256 withdraw time equal to u. Oh, it's UN 48. UN 48. UN 48 log dot timestamp plus unstake delay. Okay, that should be correct. Uh, hopefully that should be correct. Withdraw time and then call entry point dot unlock stake. Let's at least try this. If this is correct, we know struct should be correct. Yes, that's correct. Then I still want to add the I want to add the what the check for deposit info struct. So we're still gonna continue it even though it's it's done, because that's better way in my opinion. Get deposit info, and deposit info takes address dot this. Okay, so we have seen we can copy this because I know That's correct. And then deposit will be 0, this should be false, and this should be, oh, we have withdraw time. Okay, and then assert equal to abi.encode deposit info, comma kcak 256. I hope I pronounced it right, but probably not. So let's just go with it. Yeah, and now this should pass to yes. So if you see here, we have fully tested this part. Now we can go to this part. Withdraw time. We'll check what to do here. And this is pretty simple. It's not, although I don't think we have tested this, but yeah, we have probably. No, this is just us increasing the deposit of paymaster, and in that test these parts are covered, 1 2 and also 3, this also. So that's why we are getting these blue lines, but that's probably not covered yet uh, in our unit tests. So if we try to run like a single unit test, sorry, bunch of unit tests, that's why you should like put these tests in different file. So we could have understood like for stake manager, these functions are testing unit testing each of the functions from stake manager.sol. Okay, for now let's keep this in mind. Let's go. Okay, so we want to test withdraw. For withdraw we are, yeah, for withdraw, let's see, yeah, it's checking. We can do this, we can call this without doing anything and we'll get this error. Then we can stake and call this, then we'll get this error. We can stake and unlock it, but not like roll over the timestamp, roll or warp. It's roll I think, but we'll check the Foundry book for correct cheat code. But if we don't change the timestamp, we'll get this error. So we have 1 2 3 conditions for all 3 set and understood. Then at the end we are gonna, what we are gonna do is stake, call unlock, increase the timestamp so that it will go over this, go over the withdraw time. So we can withdraw the stake, then check if we are getting the this event, and if our stake is, yeah, we can call, we can send a random address here which has 0 balance, and check if we are getting this back, the correct amount back. And at the end, we can create a revert contract which reverts on uh, ether, which reverts on sorry, which reverts when it receives ether, so that we can achieve this condition. Okay, but for now I think these three should be quick to test. Function test withdraw stake reverts on no stake. Public entry point dot withdraw stake, and we can say okay, address, is it correct? Make address the receiver, oh no, yeah, and then send put receiver here. Okay, can we do this? Yes, we can. And then say vm dot expect revert to give us an error, which is this: no stake to withdraw. No stake to withdraw. Okay, that will pass. Function test withdraw stake, sorry, withdraw stake reverts on, what was the next condition? um, Called before unlock. Public, yeah, that works. Then let's try to write it. At least I'll get some practice in. Receiver equal to payable MAC address receiver, then say no, not vm dot revert, entry point dot add stake. We need to create un256 stake equal to 1 ether and unt32 unstake delay seconds. That's yes, unstake delay seconds. Set to 100. Now set value to stake and pass unstake delay as function argument. Yeah, file is way big. And then say vm dot expect revert. Let's go here, copy this part. After we copy this part, we can put it in the expect revert, then call entry point dot withdraw stake and set it to receiver. Oh, sorry. So pass receiver as the function argument. And hopefully we should pass this test. Okay, just a second. Okay. So final condition is this, where we call unlock, but we don't roll over the timestamp. Withdraw take reverts on called before withdraw time. Public address payable address payable receiver equal to payable MAC address, put receiver as the string, then UN256 take 1 ether UN32 unstake delay seconds equal to 100. Now we can call entry point dot add stake unstake delay, and then value equal to stake, and call entry point dot unlock stake and vm dot expect revert. We put the error there, and then call entry point dot withdraw and pass the receiver withdraw stake. Okay, so let's run this. Yeah, that should be good to go. Okay, let me see the coverage again. It should have improved a bit. So 80% of the functions, 65% of the lines, 70% of the branches, 70%. So we have like this branch, this so require statement at the end, require statement at the in the withdraw two functions, like there are two, so those are remaining, and lines, okay, we'll cover those. But for now I think we can end the stream a minute early. Yeah, uh, thanks for joining the stream. Hopefully you liked it. If not, let me know why. If yes, please subscribe, and see you guys tomorrow again. Have a nice day. Bye.